I'm going to share with you one of the key events arising from global warming, and it is permafrost thawing, specifically in Siberia.
Siberia. Its very name evokes up a land of mesmerizing frozen world that is home to the world's largest forest and the Earth's oldest and deepest lake. It is also home to incredible creatures like the Siberian tiger, the musk deer, wolverine, and grey wolf. But the landscape along with these creatures have been threatened by global warming. Permafrost is defined as ground that remains completely frozen for 2 or more years. Almost a quarter of exposed landmass of the northern hemisphere has permafrost underneath, most of which were formed during the glacial periods. And even in the warm interglacial period, permafrost persists in regions of high altitudes and cold climate. However, due to global warming, the amount of permafrost is decreasing and are unable to reform. This leads to massive consequences which are already underway. But how exactly are they formed in the first place? The permafrost layer of soil remains frozen all year round while the active layer thaws in spring and freezes during winter. During winter, cold conditions causes the ground to contract and crack deep into the permafrost layer. In spring, snow melt enter through these cracks into the permafrost layer where they will freeze and expand. This forms an ice wedge in the permafrost. In the next winter, the ground contract and crack again, running through existing ice wedges. This crack will again be filled with water, which will then freeze and widen the ice wedge even more. This process continues for millions of years, becoming an important part of the soil structure. Here we see the cross-sectional area of the ground with the active layer on top and the permafrost layer below. However, the permafrost is thawing for good and are unable to reform each winter. But why is permafrost thawing an important issue? Due to global warming, winters in Siberia are getting warmer and shorter. Siberia also experiences warming all year round. As such, the active layer on the ground gets heated up excessively, causing the ice wedges in the permafrost to thaw. This destabilizes the ground above it, causing a cave-in of the active layer and forming a depression in the ground. Some of these depressions are filled with water during precipitation, forming a small pond, but can quickly grow into a lake. Furthermore, as the climate becomes warmer, the active layer penetrates deeper into the ground while the permafrost recedes. If the active layer is too deep, it can only freeze in the uppermost layer, and the permafrost will be unable to reform. Collectively, this irregular land surface landscape is known as a thermocrust. Here, we see an aerial view of a town in Siberia whose landscape is heavily altered as a result of thawing permafrost. This may seem quite harmless at first sight, but what if the hollows grew to the size of craters? And this was exactly what is happening in Siberia. Betelgeuse crater is a thermocrust depression and it is the biggest permafrost crater in the world. It is known by the locals as a doorway to the underworld. This crater is 1 kilometer wide and 100 meters deep. As the permafrost thaws, long buried forests, animal carcasses, and up to 200,000 years of historical climate records were uncovered. The worrying fact is that the crater is growing at an astonishing rate. As you can see, the crater is widening and deepening rapidly through the years. Research has shown that the head wall of the crater has grown about 10 meters per year and even up to 30 meters during warmer years. In the first 6 months of 2020, Siberia experienced a period of unusually prolonged high temperatures, including a record-breaking 38 degrees Celsius in the town of Verkhoyansk on 20th June. This heat map of the Siberian region shows the change in the temperature between the January to June 2020 average temperature compared to past temperature records from 1981 to 2010. As you can see, Siberia has been experiencing an abnormally high temperature, and the heat wave has caused wide-scale impacts including wildfires and loss of permafrost. To put in perspective of the global warming situation, let me put this data in a timeline. In 2019, Russia experienced its hottest year on record. In fact, Moscow, which will usually be blanketed in snow during winter, experienced snowless winter in 2019. Come 2020, May was the globally warmest May on record. During the Siberian heat wave, 20th June was the hottest day ever recorded in the Arctic at 38 degrees Celsius. Once again, September was our globally warmest September on record. And 2020 is on track to becoming the hottest year ever, besting 2016, which currently holds the record for hottest year. As a result of the warmer temperatures, tundra fires, which was once rare, are becoming more common. As fire thaw the top layer of the soil, the permafrost below was significantly degraded in a short span of time. The picture here shows a forest fire burning in central Yakutia, which is one of the coldest regions of Russia. Forests cover over 83% of the territory, but the Siberian heat wave is causing the spread of wildfires to these supposedly cold and wet areas. This is an aerial view showing the extent of the wildfire in Siberia, and it was estimated that about 10.9 million hectares of forest were destroyed by wildfires since the start of 2020. Thawing permafrost will become completely irreversible if nothing is done to reduce global warming. This can have devastating effects such as infrastructure damage, massive greenhouse emissions, and unleashing ancient pathogens, which I will explain. When ice wedge thaws and permafrost retreats, the ground above it destabilizes and sinks. This causes the infrastructure above it to collapse into the hole. Usually, signs of caving in appears by a slight ground depression, but this usually goes undetected or ignored by residents or maintenance workers. As such, a collapse may occur and take people by surprise. The devastation of infrastructure damage is clear. Yakutsk, a city in Siberia, is the largest city built entirely on continuous permafrost. Even though they have mitigations to slow down permafrost receding, these may not be enough when global temperatures continue to rise. The next impact is the massive greenhouse emissions from thawing permafrost. Take a look at this picture here. It may look like it is Photoshop, but it is actually a photograph of one of the walls of Badegeka crater. When permafrost thaws and the land sinks, organic remains of leaves, grass, and animals that died millions of years ago during the Ice Age becomes exposed. Microbes will then begin breaking them down, releasing tons of greenhouse gases like carbon dioxide and methane into the atmosphere. This is known as positive feedback because the process releases greenhouse gases, which continues warming the Earth and in turn speeding up the permafrost thawing and expose the carbon sources even more. An estimated of 1,600 gigatons of carbon is locked in permafrost, an amount 4 times more than the total emissions since the Industrial Revolution. The last impact I will discuss is one which is very relevant to the current state of the society, and that is thawing permafrost have the potential in unleashing ancient pathogens. Here is the story. In 2016, there was an anthrax outbreak in Siberia, a highly infectious and lethal disease caused by bacteria. Investigations showed that as a result of thawing permafrost, reindeer carcasses that died in an anthrax outbreak 75 years ago were being exposed. The anthrax-like bacteria was then being picked up by grazing reindeer which infected them. Nomadic herders which was traveling with the reindeers were exposed to the infected reindeers, spreading the disease from the reindeer to human. The result of this is that 2,300 reindeers were killed. 72 of the herders, including 41 children, were hospitalized. Unfortunately, one 12-year-old boy died. Since the incident, vaccination of reindeer have resumed. This means to say that bacteria and other pathogens can remain intact when frozen in permafrost. They stay dormant for centuries until when permafrost thaws, they are once again exposed and are ready to infect your host. Pathogens like anthrax can also spread through soil and into the groundwater, which certain villagers may depend on for water supply. But this is not an isolated case. Scientists fear that there are many pathogens in wait to be revived again once the permafrost is thawed. For example, there is a serious potential risk for smallpox, a devastating disease 100 times more lethal than COVID-19 to spread again. This is because victims of the smallpox epidemic in the 1890s, which swept through Siberian settlements, were buried along the now eroding Kolyma River. In 2005, A 1918 Spanish flu strain was recovered from a body buried in permafrost in Alaska. But diseases like smallpox and anthrax that we have encountered in our recent human history is not the worst-case scenario, because we have vaccines and antibiotics to deal with them and protect us. The worst-case scenario is when unknown bacteria or viruses are emerged from thawing permafrost. These ancient pathogens could be nothing like our immune system have ever encountered and evolved with. Both humans and intermediary animals could be extremely vulnerable to the revived pathogens. For example, in 2018, 28 new virus groups were found in 15,000-year-old Tibetan glacial ice, which fortunately are not infectious to human hosts. In conclusion, climate change isn't just about destruction of infrastructure, loss of ecosystem, or experiencing extreme weather. Equally important is that climate change is also about changing what we know about diseases. If there's one thing we can learn from COVID-19, is that there are a number of steps we can take to better prepare for the next pandemic, and fighting global warming is one of them.